So hello everyone, welcome back to my YouTube channel. So today we'll be doing a second topic, that is demand forecasting. So earlier in my first video, we first understood forecasting, what are its types. So we also studied linear regression and what are regression equations, and we solved some questions based on that. So now today in demand forecasting, we'll study about many methods like exponential smoothing, moving average, seasonal variation and all. So let's start. So first of all, let's discuss, why do we need demand forecasting? Why? Why demand forecasting? So there are basically three reasons. First is, demand forecasting is to or predict likely sales in the future. Second, it is to plan their production, how much they want to produce in the upcoming years, and also prepare the budget. Prepare budget. Then we have types of forecasting. Earlier we had seen quantitative and qualitative. There are some more types. One is short-term forecasting and one is long-term forecasting. Short-term means period not greater than 1 year, and long-term means period greater than 3 years. Example of short-term forecasting is decision regarding job scheduling, job assignments, production level, and long-term forecasting examples are new product planning, R&D of that product, and facility location. So this is what is short-term and long-term forecasting. Now let's discuss what are the steps. Let's see the steps now. So the steps I'll write under Y. Steps are: first, identify the business objectives. The business objectives. Then second, determining nature of goods. Determine nature of goods under consideration. Then third, select a proper method. A proper method. And fourth is to interpret the results. Interpret the results. So now, after this, let's see classification and selection of goods. So now let's see nature of goods. Nature of goods can be: first is capital goods, second is durable consumer goods, and third is non-durable. Capital goods are goods which help in further production. Help in further production. Durable consumer groups. For first capital goods, some information required is the norm of consumption, life expectancy, growth possibilities of industry demanding such goods. These are the three information that we require. Then we have durable consumer goods. They are consumer goods which can be used repeatedly. Like there's a new demand of a certain product that was released earlier. Non-durable consumer goods are goods which can be used only once, like disposable goods, and price of one product, price of related product based on the dependence. So durable, that can be used again and again. Like we have s- a plastic polythene that we keep on using again and again. So that is basically a durable good. And one paper cup which gets which we usually throw after using it once, so that's a non-durable good. So next, let's see. Selection of method based on time horizon. You can select it based on your stability, data availability, your cost, your accuracy, or your ease of application. So let's write that. So selection based on one, time, second, stability, third, data available, fourth, cost, fifth, accuracy, sixth, ease of application. So this is what is the selection criteria. Based on these, you can select it based on time horizon, based on stability, based on the data available to you, based on the cost, based on the accuracy of the product, based on the ease of application. So now in the first video, we had seen quantitative forecasting methods in which we had studied time series models. There were three subcategories: trend projection, exponential smoothing, and moving average, which we'll be covering today. Associative models were covered in the previous video. Now there are some time series analysis. There's a short topic which you have to cover: time series analysis. Time series analysis is about time series data, that is, value of variables that are arranged chronologically. Arranged data. It attempts to forecast previous values of the time series by examining its past observations, which is the basic definition of forecasting. An assumption will be, we assume that past pattern remains unchanged. There are some reasons for fluctuation in this time series data. So let's study them. One is your secular trend. Secular trend is long run increase or decrease in data series. We'll study long run in our next video when we start production. Cyclic fluctuations. Fluctuations. Changes that reoccur over years. Third, seasonal variation. Seasonal variation, regularly recurring fluctuations. Then fourth is your irregular or random influences. They are variations that are resulting from unique events. So now let's understand each of them using a graph. So let's divide a page into four parts. We'll study four graphs. So first, secular trend. Now the graph of secular trend is, it is a steady movement of an economic variable over time. It is persistent overall upward or downward pattern due to population, technology, and this is a several years duration. Now, after this, we have cyclic component. Let's draw the graph. The graph was cyclic component. Let's draw that. Cyclical component is, so you also draw it with me because then you'll have an idea. You try to remember the graphs as much as you can. I'll draw it again. Basically a wave like, so it starts from here, then it goes here like this. So yeah. So basically it is a repeating up and down. Repeating up and down means, now see, down, up, down, up. So this can be due to weather. Sometimes it rains, many a times it rains continuously. So like that. So due to interactions of factors influencing your economy, usually it's a 2 to 10 years duration. Now then we have seasonal component. Seasonal component, we can see it's a wave like small waves with respect to time. So regular pattern of up and down fluctuation due to weather, customs. This is due to factors that influence economy. And this occurs within a year. Within a year. Then next, random component, we don't have a graph of that. Basically, it's a really erratic, unsystematic, and residual fluctuations. Like, not in a graphical way, like this. You don't have a similar form like this, or a straight line, or a curved path. It can be any path. Let's see one graph for our assumption. So let's assume earlier there was a random event occurring wherein after some time the experiment became very random. So basically this graph with time is for a short duration and is non-repeating. This can be due to cyclone. Suppose the world was going normally, but then a cyclone occurred and what had happened to the world. So this is basically what we try to see here. Earlier it's fine, but it could be that it's always random because it's a unique event. It hasn't happened before. So that is what. So next, now let's start with trend projection. Trend projection. In trend projection, we have projecting the past trend by fitting a straight line to the data. The equation is ST is equal to S naught plus BT, where ST is value of time series to be forecasted. S naught is the estimated value of time series for the base period. Base to be forecasted. B, absolute amount of growth per period, and the T is, your time period. Now, equations. You may be asking what will be the equations. Remember your regression equations. Let's write them. Y is equal to NA plus BX. XY is equal to AX plus BX squared. Replace now, what was our equation earlier? Y is equal to A plus BX. Replace Y with S naught, ST, A with S naught, T with X. Let's see our equations. Summation S is equal to N S naught plus B summation T. Summation S into T is equal to S naught summation T plus B summation T square. These are our two equations for trend projection. There are another type of equation that we can use to solve them, but we not use them so general. Usually we don't use the formula, but for your information, I'm telling you this is the formula. You need not remember this. You can derive the formula using the regression equations. Summation S upon D. Now where your D is equal to N summation T square minus summation T whole square. Now after that, let's start with seasonal variation. We can similarly, like we had regression questions, similar questions will come in trend projection. Next, seasonal variation. Seasonal variation. In seasonal variation, we have certain formulas. Ratio to trend method. Ratio is equal to actual upon trend forecast. Then seasonal adjustment is equal to average of ratios of each period, each seasonal period. And your adjusted forecast, this is very important. Adjusted forecast is equal to your trend forecast multiplied by your seasonal adjustment that you have calculated here. So 1, 2, 3, just 3 formulas and you're done. Next, let's see. We'll see one example of how to do this. So now let's see an example. An example would be you will be given a data based on a year. So you can have 1996, 1997, 1998. Then you will be given your actual sales. Let's say 5,000, 5,900, 6,200 and 6,600. Then you'll be given an equation in the question like S of t, like we did in trend projection. We'll be given an equation. Let's suppose 5 plus 28t, and you'll have to calculate your forecasted sales. Using that, you will be given in the question how you have to calculate the forecasted values. When you calculate the forecasted values, let's suppose this is 5,400, then this becomes 5,800, 6,200 and 6,800. Let's suppose. Then your ratio will be your actual upon forecasted. This is the formula that we had studied, actual upon trend forecast. Then your adjusted sale. We had done the formula earlier. Trend forecast multiplied by the seasonal adjustment. What is your seasonal adjustment? Average of ratios will be your seasonal adjustment. And when you multiply that with your trend forecast, you'll get your values here. That's all. This type of question comes. And limitations of this method are it is limited to your short-term predictions. Fluctuation in this are not considered. Assumes that historical relationships will not change. That we assumed earlier also when we had written. Next, smoothing techniques. Smoothing techniques. These are used to predict values of a time series on basis of average of its past values used when time series exhibit an irregular or a random variation. So we'll be doing moving average and exponential smoothing. Let's see now. I'll be explaining with this shorter example because it's difficult to take a big example. So you'll have quarter. Let's assume your actual A. Now you'll be given values like 1, 2, 3, 4, 5, 6, and so on. Then you'll have 20, 22, 23, 24, 18. Let me write it in a better way. 20, 22, 23, 24, 18, and 23. Now, if you are given 3/4 moving average method, then what you'll do is leave 3 values. You may ask why? It's a method. It's how we calculate it. Take the average of the first 3 values and insert it at the 4th place. So 20, 22, and 24 will be 21.67. Then after that, take the average of 22, 23, 24 and place it in the next one. So 23. Then after that we have of 24, 18 and 23 which we get as 21.67. This will be your F. You have to calculate A minus F and A minus F square. Why will you calculate this? Is for your RMSC value. Your formula of RMSC is under root A minus F square upon N. What will be the value of N here? N. We forgot to add a summation sign. N will be 6. Will it be 6? No, it will not be 6. Rather, it will be 3. Because here we have to see in the forecasted value. How many values do we have there? Not in the actual part. If we'll take these 6 as N, that will be wrong. This is not the correct method. So this was our first method. So now let's move. A criticism of this is basically that it gives equal weightage to all observations in computing the average. Next, we have exponential smoothing. In exponential smoothing, we forecast for the next period. Next period means t plus 1, which is a weighted average of the actual and forecasted values. Formula is F is equal to W A of t plus 1 minus W forecasted value of t. That means the forecasted value of t plus 1 is the W is given to you. It will be given in the question. A of t actual value of a time before that 1 minus the W into forecasted value of the previous time. And this W will always be between 0 to 1. As W approaches 1, more recent observations are given greater weightage. Now, when we, like we had in the earlier question, we'll similarly make a table, quarter, actual. It's 1, 2, 3, 4, 5, 20, 22, 23, 24, and 18. Now, how to calculate F? Given W is equal to 0.3. Then after that, we all know that we have to calculate A minus F whole square. Why? To calculate your RMSC value, which is under root summation A minus F square upon N. Now, you may be asking how to calculate the first value as we don't know any previous value. So what we'll do? The average of all values of A will be our first value. Now, after this, you calculate using the formula. Your W is zero point 0.3 into your actual value is 20 in the previous one. Now we are calculating for the second one plus zero point 0.7 into your forecasted average. Let's assume your average is 21. When you'll calculate it, you'll get the value as approximately, I don't remember, but 20.7. So you'll write here 20.7. Similarly, you'll calculate for all these values. Then you calculate A minus F and A minus F whole square. You can have W as zero point 0.7 also. Then you'll be asked to compare the RMSC. So any value of W between 0 to 1 can be asked, not necessarily 0.3. So now next, evaluation, that is what is our inference, that it gives greater weightage to recent data. Now we did not talk about what is the value of n, but so our value of n, f is full, so we'll take the value of n as 5. It is easy to update the forecast, no need to re-estimate the equations. When time trend is positive, your forecasts are likely to be too low. When time trend is negative, your forecasts are likely to be too high. Let's write this. When time trend is positive, it is too low. Negative, then it is too high forecast. Now, let's take some two questions of your homework. So, homework question number 1. Increase in number of patients due to rains or change in weather. Change in weather cause patients increase. Therefore, it is a seasonal variation. I'll not be answering the second question. The second question says, suppose you have a table in which you have values of A as 200, 400, 500, 600. You have to calculate 3-month moving average. What will be the value that we'll insert here? This is a hint. This is a very big hint for you all. Just write it and also give the value of A minus F. And one more question is there, that a time series consists of a short term, long term, and an irregular term. There is one more irregular term variation. So that's all for today. If you like the video, do like, share, comment, and subscribe to the channel. And if you feel any doubt, there's anything that you've not understood, feel free to write in the comment section. Bye bye.